Hello again, it's Dave Giles here for the seventh lesson of Cambridge International IGCSE Physics P2, Thermal Physics. Today we're looking at changes of state, and the learning objective for today is describe the energy change that take place when a substance changes state. Now, in previous learning before this, we looked at changing a state when we looked at the particle model of matter. We looked at it very briefly. So based on what we did previously, here's a short starter question. So which statement correctly describes a change of state? So if we start from the bottom, D, a solid boils to form a gas. Well, boiling is when something turns to a gas, but it's when a liquid turns to a gas, so it's not that. C, a solid condenses to form a liquid. Okay, so it's a gas condenses to form a liquid, so it's not that. B, a liquid melts to form a solid. It's the other way around. It should be a solid melts to form a liquid, so it must be A, and it is correct. A gas condenses to form a liquid. Here we're looking at evaporation. So, and melting. They both require heat or thermal energy. Um, so this is you need to add energy for these processes to happen. So you can see here melting and evaporation or boiling, and we'll look at the differences a little bit later between the two. Both require energy. On the other hand, if we go from gas to a liquid or liquid to a solid, condensing or freezing, we remove energy. So we add energy to melt, evaporate, or boil. We remove energy to condense or freeze. So thermal energy is needed to melt or evaporate as the energy is used to break the bonds in a solid or a liquid. Heat energy is needed, same as what I said there, heat energy is needed to melt or evaporate as the energy is used to break the bonds in a solid or liquid. So you can see here we've got, let's say this is a liquid, got bonds being broken by the heat or thermal energy in order to turn it into a gas. So this here is a heating curve for a substance here. So here we start with a solid. Now, solid has got the lowest level of energy, and we've got liquid and then gas. But we've got this little straight horizontal bit where the temperature doesn't change. Now, this one looks like it's for water because we've got the melting point at 0 degrees and the boiling point at 100 degrees Celsius. So as you heat a substance, its temperature will rise. However, as a substance changes state, its temperature will not change. So that is why you're getting this horizontal bit here. So if you were to heat it up and time it, you'd get a constant temperature rise until this section here, the boiling point, or depending on where you start, the melting point. So this is because during that time, energy is instead put into breaking bonds. So normally, energy is used and increases temperature. In this case, it's used to break the bonds. On the other hand, you can look at a cooling curve. So from a gas to a liquid and from a liquid to a solid. Here you've got bond making, and again, bonds are being made. So again, you get the horizontal line on the graph. So let's have a look at some past paper questions on what we just talked about from paper 2. So the table lists the melting points and the boiling points of 4 different substances, A, B, C, and D. Which substance is a gas at 25 degrees Celsius? Okay, so 25 degrees Celsius above, if we start with the top one here, the melting point is much lower, and so is the boiling point. So if it's already boiled, then it has to be A. So we're looking at the boiling point of all these are way above 25, so it can't be B, C, or D. Question 2. Which parts of the graph show change of state taking place? So even though it says time on here, during that time, energy is being added. And that energy, when it's changing state, remember, is being used to for bond making, sorry, bond breaking. So it's going to be points Q and S. So the answer is D. Similar question here, just not in a graph. Instead, this one is in the form of a table of results. What is the melting point of the substance? So the melting point, the temperature will stay the same. So the bit where the temperature is staying the same is around here. So it looks like it is 55 degrees Celsius. Question 4. Which statement describes what happens as ice at 0 degrees Celsius starts to melt to become water? So we start from the bottom. Energy is released and the temperature rises. Well, that's not true because during this point, the temperature is constant. Energy is released and the temperature remains constant. Well, the second bit right, but energy is not released. Energy is absorbed. So B has energy being absorbed, but the temperature rising, so it's not that. So therefore, it's A. Energy is absorbed and the temperature remains constant. So the answer is A. And finally, equal mass of two different liquids are heated using the same heater. The graph shows how the temperature of each liquid changes with time. What does the graph tell us about the liquids? So if we start from the bottom, liquid 1 starts to boil sooner than liquid 2. So that isn't true because it looks like liquid 1 starts to boil later. C, liquid 1 starts to melt sooner than liquid 2. Also not true. B, liquid 1 has a higher boiling point than liquid 2. We can see that here. It is much higher. So the answer is B. Okay, so that is the last of the paper 2 questions. Thank you very much, everyone. So the next lesson will be on evaporation. And again, as usual, I will post the link to the next lesson below. Thank you.